Okay, hello everyone, and we'll be discussing today's weekly contest. The date for today is 7th of January 2024, and we'll be discussing the solutions for weekly contest number 379. So, let's move on to the screen. Okay, let's see what we have for the contest. Weekly contest number 379. Just a brief overview of a brief review from my side of how the contest was. I would say that again, as we had seen in the last two, three contests, that the first three problems were fairly simple, okay, and the last one was a difficult problem. So I would expect that if one has to secure a rank of, let's say, under 300 or under 400 for this contest, so you should have solved the first three problems within, let's say, 10 to 15 minutes. So this is what we have seen in the other contests, and this is what we have seen in this contest as well. So let's move on to the problem statements. We'll discuss each problem statement one by one. Okay. Spare me for the mic today. The mic's not good. So yeah, let's move on to the discussions. Okay. We have been given a 2D integer array dimensions for all indices I. Dimensions I0 represents the length, and the first element of this 2D array represents the width of the rectangle I. We need to return the area of the rectangle having the longest diagonal. If there are multiple rectangles with the longest diagonal, we need to return the area of the rectangle which having the maximum area. Okay. So let's just move on to the whiteboard first. Okay. All right. Let's see what we have for today. Let's check. Okay. Okay. Yeah. This is contest 379. We are discussing problem 1. Okay. This is a fairly simple problem. So what we have been given is we have been given a 2D array. Okay. And this is something like this. It's a 2D array. Okay. And we have been given the size of all these arrays within this 2D array is 2. Okay. All right. The zeroth index element of each of them represents the length, and the first element represents breadth, okay, or width. All right. Now we need to tell that which one of this of the out of all these arrays, which one is having the longest diagonal. Okay, and based on that, we need to return the longest area. That whichever of them is having the longest diagonal, we should return the area for that. And just in case if, let's say, length of two diagonals are equal for two subarrays, let's say the lengths of two diagonals are equal, then we need to return the maximum area out of these two. Okay, let's say it has L1 B1 and it has L2 B2. So if D1 and D2 is equal, then we need to check which is greater, L into B1 or LB2 into L2. Okay, so whichever will be greater, we'll be returning that value. Okay, this is how we need to do. Okay, now let me add a new page for this. Okay, so I don't think there is a need for calculating the diagonal. Okay, if I see a rectangle, all right, let's say this is my rectangle, this is breadth and this is length. Okay, and this will be a diagonal. Okay, because it is a right angled one. Okay, so we know for a right angled triangle, the diagonal would be L square plus B square is equals to D square. Okay, so I can simply just check this value. This is D square, so the diagonal would be under root of L square plus B square. But why should I take the under root? Okay, let's say this is D1, okay, and D2 is equals to some L dash square plus B dash square for some other array. Okay. Now, if I want to check if D1 is greater than D2, okay, if D1 is greater than D2, if this is the condition, then I know for sure that D1 square would be greater than D2 square. This is very obvious. Okay. So why should I take the square root? I can simply just check the squares. Okay. That whichever is having the greatest square, we'll simply just return that one. Okay. So this is how we'll be doing this problem. So this is the discussion. This is how we'll be, this is the approach for our question. So let's see how do we solve this one. Okay. You just add a for loop. Okay. You iterate over, you iterate over all sub-arrays, okay? All the arrays within this 2D array, not sub-arrays. All the arrays within this 2D array dimensions, okay? And for every element, let's say you will maintain two variables. That is, one is for the diagonal, max, d max, that is max diagonal, okay? So initialize this by 0 and area, okay? This is the max area we have till now. Okay. So for every element, let's say dimensions, and denoting that by dimension, dim. Okay. So dim of I of 0, this is my L. Okay. And dim I of 1, this is my breadth. So I just need to check L square plus B square is greater than D max. Okay. If it is, okay. So I'll update my D max to L square plus B square, and I'll update my area to L into B. That's it. Okay, that is all you need to do. Okay. Another case would be, we'll move on to the next one. We'll do this properly. Let's. Okay. So we had our for loop here. This is how we had begun. I, okay, L is equals to dimension, sorry, I 0, and breadth is dimensions I1. Okay. So I'll just check, and we have two variables as stated. D max, okay, is 0. Initialized area is equals to again 0. Okay. So if L square plus B square, okay, this is all you need to do in this question. This is exactly the code I'm writing, which will get accepted. If this is greater than this, then there is only one case that you will update this. Okay. We'll update this L square plus B square, and you'll update area to L into B. Alright, simple. Else if L square plus B square is equal to D max, okay, not greater than, because we need to take for the case of equals as well, okay. In that case, what we are doing is L square plus B square, so there's no need for updating D max now because it is already the correct value. I'll just check if my current area, this is my current area, the AR variable that we are storing, okay. If L into B is greater than this value, okay. If it is, then you just update your area, okay. Area is equals to L into B. That is what they had said, that if two diagonals are having the same length, then you need to check the area and you need to return the maximum area, okay. So we have checked this, and that's it. So this is where your loop ends. Okay, this is how your loop ends, and you come out of the loop and you just return area. Okay, that's it. The complexity for this code will be O of n. Okay, because we are just iterating over the dimensions. Okay, rest of them are all mathematical operations. So the time complexity would be O of n, and we are not using any additional space as such. The space complexity would be O of 1. Okay, all right. So let's move on to the next problem. That is problem 2. This seemed to be a difficult problem, but if you read the script properly, then you will realize that it's a very simple problem. Okay. Let's see this. Okay. Let's see the question. Okay. Minimum moves to capture the queen. Okay. So there is a one index 8 into 8 chessboard containing three pieces. Okay. So we have been given a chessboard and it has three pieces. Okay. You have six integers A, B, C, D, E, F. Okay. So let's see what these denote. A comma B denotes the position of the white rook. Okay, A comma B denotes the position of the white rook. Okay, so if you are not aware of chess, then this is what is called as the rook. In Hindi, in our households, we used to call this as hathi as well. Okay, elephant. Few people call this as an elephant, but actually the name is a rook. Okay, so this is your rook. Okay, this is the position. A comma B denotes the position of rook. C comma D denotes the position of the white bishop. Okay, bishop is horse in, so not horse, sorry, that camel. In a, if I were to take very household type of, very Indian household type of a name, then people used to call this as the oot. Okay, so yeah, this is our bishop. Okay, it can move only diagonally. Okay, and if you are aware of the moves of the rook, then the rook can move horizontally and vertically up and down. Okay, right, left, up and down. Doesn't matter how many steps, it can take any number of steps. Okay, and so for the bishop, it can move diagonally this way, this way, this way, or this way within the chessboard, and any number of moves. Okay. Last we have E comma F denoting the position of the black queen. Okay. So queen is, again, I hope all of you are aware of this, the strongest, I would say the strongest piece of the chessboard. So yeah, it's a very important piece on the chessboard. Okay. So the queen can move all the moves. Okay, we'll just discuss that once. Okay, given that you only move the white pieces. Okay, so they have said that the queen does not move at any cost. We are not moving the queen, we are just moving our rook and our bishop. We need to return the number of moves required to capture the black queen. Okay, so we need to return the minimum number of moves that would be sufficient to capture the black queen if the queen is not moving at all. Okay, and we can move our bishop and rook as the way we like. Okay, let's see the notes as well. Rook can move any number of squares either vertically or horizontally as stated, but cannot jump over pieces. Okay, so I hope all of you are aware of this. You can move any number of steps horizontally or vertically, but you cannot jump over any piece. Okay, bishops can move any number of squares diagonally, but cannot jump. Okay, rook and a bishop can capture the queen if it is located in a square that they can move to. Okay, that's, again, it's pretty obvious. The queen does not move, so they have already given that. So let's move on to the whiteboard for this. Let's see how we'll do this. Okay, so let's make a chessboard for this. This is a fairly simple problem, and I think the complexity for this would be O of 1. Okay, because we have only 8 into 8 chessboard they have given us. Okay, so there is no variable n in this case. Okay, how many? 1, 2, 3, 4, 5, 6, 7, and the last one 8. Okay, now let me make 8 rows as well. Okay. 1, 2, 3, 4, 5, 6. Okay, let's take 7 here and let's take 8 at the beginning. Okay, so we are done with our board. Okay, this is our chessboard. Let's say, spare me for my drawing as always. Okay, so let's say if this is my rook, so rook can move like this, any number of steps, like this, any number of steps, like this, and like this. Okay, and let's say my bishop is here, so bishop can move any number of steps to this diagonal, or to this diagonal, or to this diagonal, or to this diagonal. Okay, so this is how the bishop moves. Just for your reference, although we don't need that in this question, the queen can move like this in any of the directions, any number of steps. Okay, so the queen can take all the moves. If I combine the moves for the rook and the bishop, so it can take all the moves. Okay, all right. So that is why it's the strongest one. Now let's get back to the question. Okay, so it is pretty clear that if the queen exists in the same row or the same column as my rook, okay, so I can capture the queen in one step. Okay, pretty obvious. Okay, because I can simply just move to that queen and I'll be able to capture it, and we do not have any other pieces in between. Okay, so that is pretty clear. Okay, that the queen can be captured like this pretty easily. Okay, now or it could be here, or it could be here as well. Within, let's say this is inside the chessboard somewhere here. Okay. So if it is in the same row or same column as the rook, it can be captured. Okay. Now see one thing, that this is one step. Okay. Now let's suppose that the queen lies somewhere here. Okay. Somewhere here. Now and the rook is here. So you see that the queen is not in the same row and the same column as my rook. So what is the minimum number of steps I can take? If you observe this carefully, I can simply just move to this spot and I can simply just move to this spot, capture it. So this is two steps. Or I can move to this point and then I can move horizontally. So this is again 2 points. So if you observe this carefully, wherever your queen may be, okay, if it is in the same row or same column as the rook, it can be captured in one step. But if it is not, even in that case, you can capture it in two steps in any position, even if it is somewhere here. So I can simply just go this way and I can go this way, or I can go this way down and then I can go horizontally right. So either I'll be able to capture my queen in one step or I'll be able to capture my queen in two steps. So the answer would always be either one or two. It cannot be any value greater than two. Okay, it cannot be any value greater than two. This is not possible. For the minimum moves, I can always do it in two steps by just doing this two moves from my rook. Okay. Now, how does the bishop come into picture? This is important to visualize that for for bishop, you see again for bishop it is we do not care whether we can capture the queen in two steps or not from the bishop. Okay, so I just need to check whether I can capture my queen using my bishop in a single move. Okay, that is all I need to check. So I just need to check if my queen lies diagonally at any of the diagonals to this bishop. Okay, that is all I need to check. If it is diagonal, then I'll return 1, else I'll return 2. Okay, simple as that. So the answer would be 1 or 2 in every case, no matter what. Okay. Now, again, as that is why I was saying that this is going to be a single line, what do you call as constant time complexity based solution. Okay, because let's say we have the positions of A, B, for my rook, CD for my bishop, and EF for my queen. Okay, so I can simply check if it is in the same row or same column. Let's say this is row, the first ones, and the second one would be column. Okay, so firstly for checking with the rook, okay, I'll just need to check if A is equals to E or B is equals to F. If either of this condition holds true, so I'll return 1. Okay, I'll just return 1. Okay. Similarly, we can check for the diagonal now. From the bishop to the queen. If it is possible uh, to capture the queen in one move by using our bishop. Okay. So how do we check the diagonal? Okay. Let's say this is my CD point and this is my EF point. Okay. You just need to move yourself till this, and check if it is diagonal or not. Or what you can do is you can take the difference between, let's say, C and E. Okay. Let's say this value is X. Okay. So if you're moving diagonal from a point, if you're moving, say, let's say diagonal, okay, X steps, okay, if you're moving X steps diagonal, all right, and this point is CD. So what will be the coordinates for this point? The coordinates you're moving on a whiteboard, take it like a grid only, okay. So where are you moving? You are moving from C minus X and D plus X. Okay, this is where you are moving. All right, you just need to take your moves. Okay, you need to take the difference between C and E, and you just need to check all the possibilities that if you take those X steps, X is C minus E. If you take those X steps from your D, so will you be able to reach E comma F or not? Okay, this is how you check it. Okay, now let me just rub this once. It's very shabby. Okay, I hope all of you can do this on your own. Okay, so this is the first condition. Okay, else if I check, if this does not hold true, I check, let's say I'm creating a separate function for checking the diagonal. Okay. So I'm just passing that C, D, E, F as parameters. If it is true, then again you return 1. Because if it is diagonal, then you can always capture your queen in one step. Okay. Now both the cases for 1 are done. And what did I say to you in the last page, that the answer can be either 1 or 2. It cannot be any other value. And we do not care how do we reach that 2 point. Okay. We know that from our rook we can always take those 2 steps. So I'll just simply return 2 here. Okay. How did I do that? Let's reiterate through this. This is the first condition. If this holds true, so we return 1. Else if the second holds true, we return 1 for the bishop. Okay. This is for the bishop. This is for the rook. Else, well, if none of the condition holds true, so I can simply just return 2 true. This is not true 2. I can simply just return 2. Okay. That's it. That is all we are doing. Again, the time complexity for this code is O of 1. Okay. So again, I would take this as a fairly simple problem. All right. Let's move on to the next question now. Okay. You are given two indexed integer arrays, nums1 and nums2 of even length. You must remove n by 2 elements from nums1 and n by 2 elements from nums2. After the removals, you insert the remaining elements of nums1 and nums2 into a set S. Return the maximum possible size of the set. Okay, okay. So we have been given two arrays. We need to remove half of the elements from each one of them, and the remaining n elements from the remaining n by 2 elements from both of them. We just need to push all of them in a set, and we need to check what is the maximum possible size of the set. So just to point it out again, just to clear this again, that why are we mentioning the why is the uh, setter mentioning the set data structure? Because you can only store distinct values inside your set. Okay, let's say I push the value 2 3 times to my set, so it will be only present once. Okay, because it only stores unique values, the simple set, be it the unordered one or be it the ordered one. So it can only store a single instance of a value. Okay. Now think about a greedy solution for this. That what would you take? Okay. There is not much discussions to this question because this can be done very easily. Okay. So what we'll be doing here is that greedily what you should do to increase your size. Okay. The elements which are present in one of them. Okay. We have two arrays. Okay. Nums1 and nums2. Okay. So if there is an element, let's say E, which is only present in the first one and it is not present in the second one, so of course I will try to push it to my set. Okay, because I want to increase the maximum number, right? I just need to increase the maximum size of my set. So if there are some values which are present in only one of the arrays, so I will surely push those elements first. Okay, that will be my preference always, right? So no matter, and keep that in mind, for every element we need to push it only once. Okay, even if some element, let's say it is present here 100 times. Okay, let's suppose that the size of the array is 10 power 5 and this is present 100 times. So I'll push it to my set only once, and the rest 99 instances I'll discard all of them. Because why would I take those values? It doesn't matter. Even if I push them, then also I'll be having only one instance. Okay, so why should I waste my count? It might be a possibility that there is some other elements, some 99 other elements which are distinct. So I would push those elements, right? Why would I push 99 instances of this element only? Okay, so this is what you need to do in this question. That you firstly need to check. Let's move on to the next page. Okay, problem 3. You firstly need to check, let's say you create a map data structure. Okay. Uh, yeah, wait a minute. What is the constraints? Let me just check the constraints again. 10 power 4. Okay, we need to do it in O of n kind of a solution. O of n or O of n log n. Okay. So, all right. So we can check which elements are distinct in my distinct array. Okay. How do I check that? I can probably create a pair here. Okay. Not pair. Let's not create a pair. Okay. Integer comma integer. Okay. Let's take an integer comma integer map. Okay. So I'll iterate over my first array. Okay. And I'll mark it true if an element is present here. Okay. So I'll mark it true. Okay. If it is present, let's say np of e is equals to 1. I am not doing np of e plus plus. Okay. I'm not doing this step. Okay. And I'm iterating over my array one, the first one till the time. Okay. I'm not doing this step. I'm just doing this one. Okay. np of e. So I mark them to true. Then I iterate over the other set of elements. Okay. All right. I iterate over the other set of elements in the second array. Okay. This time I'll do np. If it is, I'll check if a particular element is already true. That means it has been. It is what do you call it as? It is. It was already present in the first array. That would mean okay. So if I just do this thing, okay, np of e, alright, np of e is equals to already 1. If it is already 1, then I change the count to 2. Okay. I'll just change the count to 2. That is what I'll do. Alright. That's it. So now I have all those elements with the count marked as 2. Okay. I'll iterate over my map. Okay. Iterated comma map. Okay. I'll iterate over my map and I'll check for which elements the count is 2. Okay. I'm writing this code in C++ kind of a thing. Okay. So I'll check for which of them sorry, MP of iterator. Yeah, this is correct. Okay. So for which elements, if it is 2, then I'll add those elements to my set. So I'll create a counter variable here. This denotes the size of my set. So I'll just do count plus plus. This is my first iteration. Okay. So I'll just add all those elements. Okay. And you see the maximum possible value for count can be n. Okay. So I'll just run this complete for loop. If I come out of the loop and if my size is greater than n, greater than or equal to n already, that means there are that many distinct elements present in both of them. So I'll simply just return n because we know that the maximum possible size of the set can be n only. So I'll simply just return n. And if it is less than n, okay, what I'll do in that case is, let's move on to the next page. What I'll do in that case is, I'll again iterate over my map. Okay. This time I'll check the values. Okay. Okay, wait a minute. This time, sorry, I think I made a mistake here. Yeah, this should be one. Sorry, because we need to check the different elements, right? So this will be one. This won't be two. Okay. So I'll just check one. Okay. This time I'll check which values have a count of two. Okay. Iterator dot second is equals to 2, and I'll just increment the count for these elements now. And when I come out, I'll again check that if count is greater than n by any chance, although it won't be possible practically. If it is greater than n, so you just return n in this case. Okay. Else greater than equal to n, so you return n in this case. Else you just return count. That's it. Okay. That ends the code. So we just the approach boils down to, okay. I'll just put a few pointers. Check all distinct values in both of them. Okay. Distinct values for in both arrays. Okay. Both the arrays. This is the first step. Okay. The next step would be check if the count after the first step is greater than or equal to n. In that case, return n. Okay. Else, what do you do? That now you check all same elements in both the arrays, the elements which are repeating in both of them. Okay, same elements. Okay, and after that you just need to repeat step 2. Okay, repeat step 2 again, check if it is greater than equal to n, and last just return count. Okay, that is what you need to do. Okay. So this is all we are doing for this problem. Again, this problem, you can, instead of a map, you can use a set data structure here as well, okay, for storing the distinct values. All right. So perhaps that will give you a much better idea. Okay. So you'll have to use a map as well as a set for this. Okay. So yeah, the complexity for this question would be n log n. Okay, because we are iterating over both the arrays of size n, and for insertions and deletions from a map and a set, the complexity would be log of n. The complexity overall becomes n log n. Okay, this finishes the first three problems. Okay, now let's move on to a very good problem. Although this was a DT problem, okay, we'll see the code for this as well, because rest of them didn't feel like I didn't feel like doing a code for them because they were fairly simple. So for this problem, we'll be discussing the code as well. Let's see the problem statement first. Okay, all right. Wait a minute. No, not this one. Yeah, this is the question. Okay, just move on to the discussions for it. Okay. In the meantime, let's read the question. Okay. So we are given a zero index string s and an integer k. Okay. We have a string and an integer. You can perform the following operations until s is empty. Okay. So we have been given an operation and we can perform it until s becomes empty. So we choose the longest prefix of s, not x. We choose the longest prefix of s containing at most k distinct characters. Okay. Delete this prefix from s and increase the number of partitions by 1. Okay. And the remaining characters would maintain their initial order. This is what we have been given. Before the operations, you are now, this is a very important point. Before the operations, you are allowed to change at most one index in S to another lowercase English letter. Okay. So before the operations, we can change at most one index. It is up to us whether we want to do it or we don't want to do it. And we can change any index just once. Okay. We can just choose one index and we can change its value to any other lowercase English letter. Return an integer denoting the maximum number of resulting partitions after the operations by optimally choosing at most one index in to change. Okay. So what we have been asked that we need to choose that index and we need to choose it in such a way that the number of partitions increases. Okay. And where do we do the partitions? By selecting a prefix with at most k distinct characters and by removing that prefix. Okay. This is how we are doing it. Okay. Now, if you read this question properly, this would surely give you a vibe of that dynamic programming based question. Okay. Because you see, they have asked us to optimally choose at most one index. So we can have sub problems in this question. Okay. So therefore, it would be a dynamic programming question. Okay. So when it comes to dynamic programming, I'll just briefly explain you the approach because we'll understand the code for this. Okay. So what we will be doing now, we are going for dynamic programming. And what we are doing in dynamic programming, we are selecting the index to change. Okay. This is what we are doing. This is how we are applying dynamic programming here. That we are selecting the index to change. Where we'll do a dynamic programming in this concept. That we'll select all of each index by recursion. We'll put some value. Okay. And then we'll just check whether we are getting a good answer or not. What are the possible values? There can be any value. The character, let's say it is denoted by char, so it can be any value between A to Z. Okay, because they have asked that lowercase English letter. So this can be maximum 26 cases for this. Okay, and I can take any value from 0 till n, that is the string length. Okay, so this is what we are doing. Okay, all right, so let's see how we do this. Okay, again, this is dynamic programming, so it will be something like, let's say I've chosen the character I as my character and I'm putting some character, let's say C here, char here. Okay, I'm changing its value to char. Okay, now I need to check the dynamic programming for I plus 1. Okay, with no operations because I've applied an operation on this step. Okay, so I cannot apply it in past. Okay, so I'll do no operation here. Okay, I plus 1 till this, so we'll calculate the dp for this, and similarly we need to calculate the dp for 0 till I minus 1. Okay, with no operations. Okay, no operations, this is what we can do. Okay, this is one case. Let's move on to a separate page. Okay, so our dp would be this thing. Okay, uh, 0 till I minus 1 and no operations. I'm denoting this by 0 plus, because we have changed the current one now, so we need to calculate it from again I till n minus 1 for 0 operations. Okay, this is one case. Now let's say I didn't change this one, so I could have simply calculated the dp for 0 till I minus 1. Okay, with any possible operation we can do an operation here. Okay, we can do an operation here, plus I have not changed this one, so I'll calculate the answer for this case. Okay, so whatever gives us a maximum value, we'll just return that. Okay, nx, let's say denoted by nx. Okay, this is how we are doing. Let's firstly see the code for this. You'll get a better idea, then we'll come back to the whiteboard ones. Okay, okay, I'll just increase my screen size here once we all right. Okay, so I've denoted not operation not allowed by 0, that we cannot do an operation, and allow by 1. You can simply just do it by 0 and 1, it's up to you. Okay, so let's see what we are passing into our string. Okay, in our DP, sorry, I've added this the name as DFS. Okay, okay. So for storing the state, I'm creating a vector integer of unordered none. Okay. We'll get this data structure once, okay, but when we are moving with the code further. So what parameters I'm passing now in my function? Now let's just see my function. This is my current character. Okay. This is my string. Okay. This is my current status. This is very important that if you're aware of bit masking, a few of you guys are aware of bit masking. So if you see, you can mark whether each character is visited or not by using a bit mask. You have 26 characters. Okay, so let's say I'm marking the fifth character of alphabet. So I can simply just do, let's say this value is x. Initially this is 0. So I can simply just do x is equals to x or 1, 5. Okay, so this will mark the fifth bit from the beginning, which would mean that I have already used the fifth character of the alphabets. Okay, so that is why I'm using a bit mask here. Allow change. Okay, whether the change is allowed or not. This value would be 1 or 0. Okay, so if you see initially this value is 1 because allow is marked as 1, and then I'm passing my memoization. You can also store this globally, that's up to you. Okay, and this is the variable k, that is the maximum the number of distinct characters in a particular substring. Okay, now I need to check what I'll do. Okay, let's just go over this. For the ith character, let's say I decide to change it. Okay, for the ith character, I can take any character from 0 to 26 because there are 24 alphabets. So therefore, I'm taking this as numbers at the moment. I'm not taking actual alphabets. Okay. So if J is equals to C, what is C? C is my current character. S of I minus A. That is the value of the, let's say if S of I is A. So A minus A would be 0. Okay. So if I'm replacing uh, uh, ith character by j, some value. So I need to check the value for the ith character, right? And that value is S of I minus A. So if it is same, so there is no point of making a replacement here, okay? Because this is already, we already have this value. Why would I make a change, okay? So I've created four variables here, okay? Return, this status, and this allow change. So this allow change would be my current value only. Because if I'm not making any change, so I can take the value from the previous dynamic programming. So I'll just take the current change as the previous one only, okay? Else, I'll check if my allow change is not allowed. That is, I've already made a change. So I cannot make a change in future now. So I just continue. I cannot do anything here. Okay. And if it is not the case, that means that if it is allowed, that the operation is allowed. So I'll try to make a change here. Okay. I'll try to make a change here. I've made a change here and I'll change my status to current status. That is the current bit mask into this new change, which I said one greater j. So this is how you mark your bits. Okay. So this is how I have marked my bits. This is my current status. If I make a change, I am not saying that I have made this change. I am checking that if for the ith character, if I replace it by j, if I replace it by the jth alphabet character, then will this improve my answer or not? So that is why I have marked this status as this status. I have not changed current status. I am changing this status. Okay, that is, this could be a possible status. Okay, so yeah, I just check this built-in pop count is to check built-in function to check if how many bits are set in our mask. Okay, so I'll just check how many bits are set. If that value is greater than k, that means I'm having more than k characters already, which is not allowed. We are allowed at max k distinct characters. Okay, so for k distinct characters, I cannot, if it is greater than k, then I cannot make this change. Okay, I cannot do this. All right. So I'll just move on to I plus 1. Okay. I just move on to the next one. Okay, I'll take this as a partition now because if it is greater than k, then of course I cannot make a partition, right? So I'll just uh, take if it is greater than k, then I cannot make a partition here. Okay, well, I cannot include it in my answer. So I'll make a partition here and I'll move on to the next index I plus 1. So I move on to I plus 1, the string s, and I'll take a new bit mask this time because for a new index, okay, this is for the ith index, the value I'm replacing. Till I minus 1, I have already done. For the ith one, I cannot include it for the, see, for the ith character, I cannot include it with I minus 1 because the value would become greater than k. So for the ith one, I need to restart my bit mask. So I'll start my bit mask with the current jth character as marked. Okay. And this allow change. Okay. Whatever the value is. And this two values will be static. Okay. Else, this is the first case wherein we cannot make a change. Else, what I can do is I can make a change. So I'll make a change here. Okay. I'll do I plus 1 s this status. Okay. Because this status would have less than or equal to k bits. Okay. So I have this one as my current bit mask. I'll change this allow change, okay, and memoization and claim. That's it, okay. And I'll just take the maximum value. Return is the global maximum. This return is the current maximum, the current maximum number of partition. So I'll update the global maximum of return with this return, okay, and I just add it to my memoization. Okay, I allow change and current status. Okay, now let's see how we are using the map here. What was our memoization denoting? N plus 1 to denote the index of the string. Okay, and vector unordered map. Okay, we have marked the size as 2. Okay, because we have two values only, that is allow change and current status. Okay, so the two values here. Okay, and I'll mark this as return and that's it. So I'm just simply returning the updated value. Now let's see where I've added my bit mask, that no, the base condition, let's see. Okay. Okay. So if I is greater than equal to the string dot length, okay, that means I've reached the end and the current status is still greater than 0. Okay, if it is equal to 0, that means there was some problem in between, because if it is 0, that would mean I do not have any characters marked. Okay, so why should I make a partition here? Okay, that means till n minus 1 I had made all my partitions. So why should I make a partition at this point now, which is at the very last? So only if this value is greater than 0. That would mean that for the last partition we didn't find more than k characters, and we kept on looking for further indexes. Okay, so we didn't find at max k characters or a better case. So we kept on looking, and when we reach here, so we'll just check if this value is greater than 0. Now we need to stop because we have exhausted all our characters. So this is the maximum possible value we can get. So I'll just check current status is greater than 0. So this is like a ternary operator. So this will return 1, else it will return 0. Okay. Even if you do not add this will work perfectly fine. Okay. Right. This is just the memoization step. Okay. Memoization, if it is already present, if we have already calculated, that is what we do in DP. So why to recalculate it? We'll simply just return that value. Those what values are changing? The index is changing, the status is changing, and this allow change parameter is changing. This is all that is changing here. Okay. We just had this value, simple as that. Okay. And yeah, this finishes our code. Okay, and we'll just call it here. This is how we are calling the function. Initially I will be 0, string s. Current status is 0 because we have not included any character yet, so the bit mask is 0. Initially the operation is allowed, so we mark it as 1, and we are passing this memoization vector, and we are passing the k variable which has been given to us in the question. So yeah, this is how we'll do this question. There is another approach for this regarding the prefixes, that you can store prefix and suffix for all of them, and then you can make change to the ith character. But that would be very difficult to do in a contest duration. Although this problem itself was very difficult to solve in the contest duration. So I'll rate this problem as a very, very difficult problem for from a contest point of view. And I don't think more than 50, 60 people were able to solve this question in the contest. So yeah. For the first problem, let's do a review for this. The first problem, that was, let's say, a 1 star problem. The second problem was again a 1 out of 5 problem. The third problem was, let's say, 2.5 out of 5. And the last problem, okay, that was a 4.5 star 5 according to me. So these first three problems, this could have been done in 15 minutes. Okay, if you want to solve this question, you need to have a lot of practice. Okay, but again, 1 hour would have been sufficient for this if you could recognize the dynamic programming. Okay, so yeah, if you want to have any rank under 500 or 400, then you should have solved these three questions in 15 minutes, I believe. So with no wrong submissions. So yeah, this was the discussion of the contest for today. I hope all of you enjoyed. Please feel free to leave your comments in the chat section if you have any recommendations for me, and if you have any doubts with the discussions. Okay, because your review is very important for me. It would give me motivation to make more such videos, cover more such contests from my schedule. So yes, let's meet next week for the weekly contest 380. And till that time, happy learning, stay safe, stay healthy, and have a nice weekend. Bye bye.